Hi, this is Mrs. Slater, and today we're going to talk about lines and planes. And first of all, the definition of a plane, if you recall, is a flat surface with infinite length and width. And when we draw them, you're going to see planes represented with a parallelogram shape. Okay, so you can use your geometry to make a nice sketch of that. And also, things that you should know is a plane is going to be a lowercase letter in one of the corners. And for this one, I'm just going to put an M, so we would call this plane M. And again, it's the lowercase letter. Okay, another thing you should know is when you're drawing lines in planes, if it's lying on it, you can just say that AB is on plane M. Or if you want to go through it, you have a line like this. There's going to be a point right here, maybe at B, but there's going to be a part that you can't see, so we're going to make that dotted, and then it would be solid again as it comes out underneath the plane. So line BQ is intersecting the plane, and that's how you can demonstrate that in the notes and anything you see from now on. Okay, and then also what I'd like to talk about is what the definition of foot is. Okay, a foot is the point of intersection of a line and a plane. So in this picture, we would say that B is the foot of a line, I guess we don't need to write out the word line, of line QB in plane M. So you're describing where the line is and where the plane and what plane it is going through. Okay. So if you know those basic concepts, then the rest will fall into place. So let's go ahead and talk about the 4 ways to determine a plane. The first one is 3 non-collinear points determine a plane. And the example I have of this is something you may have already used in your own life, is a tripod. So the only reason that it stands the way it does stand is because it is laying on a plane. And they are 3 non-collinear points. If a tripod was a bipod, think about that. Could you actually take any videos with a bipod? No, I don't think so. So that is an example of what it means to have 3 non-collinear points to determine a plane. Okay, so let's go on to the second one, which is a line and a point not on the line determine a plane. Sorry about that. Okay, and the example I have here is something you may also have seen before, and that is a recipe holder, or even to hold music. You can see that the 2 points, or the 1 point right here, it's not on the line, and then here is the line. So the only way that they can stand this as it is because that those 2 are on the same plane, or the counter in your kitchen. So if you can get a line and a point not on the line, that's going to also determine a plane. The third one is 2 intersecting lines also determine a plane. And the example I have for this may be a childhood toy, but I know I just got my daughter one of these. But it is a paper doll that you can actually stand because it is 2 intersecting lines at the bottom. So if you look closely, there is a paper here, so that's going to be one of the two intersecting lines, and the other one starts in the front and then it'll continue in the back, and that's what's creating this paper doll to stand by itself. So that is an example of two intersecting lines determining a plane. And then the last one is going to be parallel. So two parallel lines also determine a plane. Okay, and the example I have here are just putting up shelves. So you'll see, I've got two sets of them here, that if you look at this one and this one, those are parallel lines, and that is the only way that we can get that shelf to sit properly on there. The last two postulates also relate to planes, and let's practice our skills in drawing right here. If a line intersects a plane not containing it, then the intersection is exactly 1 point. So we've already started this. Again, a plane is usually represented by a parallelogram. So I'm going to go ahead and draw that first. Again, geometry would be a good idea here. And if I'm going to draw a point that it's going to go through exactly 1 point, we're drawing a line. So again, this line, there's its foot, and dotted line represents you can't see, and then solid line after that. So it says a line intersects a plane not containing it. Then the intersection is exactly 1 point. Very good. And that point would be point P, is the intersection. Okay, and then for the second one that you need to also be aware of is two planes intersecting. This one's a little more tricky to draw. So one step at a time. If we have a parallelogram, let's say this one is standing up, I guess you could say, and the other one is going to be this way. Now keep in mind, I said if you can't see it, then you should have a dotted line. So let's see if we can make a dotted line. And I want this to be behind, so I'm going to consider that the dotted line, because I really can't see that, and I can't see this one as well. Okay, everything else, all the other edges that I can see are going to be there, so I'm going to go ahead and dot this one. Don't know what's happening on my smartboard. And then I also want to dot this in green, because I cannot see the back. Okay, so then what we can do here is where they're intersecting, I can draw a line that is connecting the two of them, because that is the answer to the question. No, not even a question, answer to the theorem. Two planes intersect, so I have my green and my blue one intersecting, and they're going to intersect at exactly one line. And that intersection point is going to be line AB. And the reason why it's a line, because remember our definition of a plane, that it's infinite length and width, so it is going to go on forever, just as a line goes on forever in both directions. Okay, now let's apply all of these different postulates and theorems. I'd like you to push pause and go ahead and try these 5 questions and then return. Okay, so let's check your answers. The first one is intersection. So M intersects N at line AB. So that is where they're going to connect. If you can extend it, that might help. And then ABV. ABV, if you need to see some visual here. A and B and V live here, and the only plane that they're all on is going to be plane M. Okay, and then the foot is point P, because that is where the intersection of the line and the plane. A, B, and RS are on plane N only, so that would be the only one it's going to determine. And AB and point R lie or determine plane N. So you can use S as well, so that's why I put that there. So now try the next 5 with the following picture. Push pause, please. Again, let's check answers. W does not lie in plane N. AB and line WV determine the plane. And you got 2 choices for H and I. Check your work there. And then J, the one thing we can know now is that line RS is going to be lying in plane N. Okay, the next one, go ahead and push pause and fill out all the given information. And then decide how can we get BAD congruent to CAD. Well, we already know that we have congruent sides and we have right angles, so this is going to lead us to proving these triangles are congruent by RHL. So the next step would be to saying that those are right angles. And because they are perpendicular, so if perpendicular, then you're going to have right angles. And those right angles would be angle ADB and ADC are going to be right angles, because if perp, then right angles. And we also know reflexive AD is congruent to AD because of the reflexive property. And if we know the reflexive property, then we have our hypotenuse and we have a leg. So the only thing left would be to say that ADB is congruent to ADC to get all three parts congruent to each other. If right angles, then congruent. Okay, so then now we can say that the two triangles are congruent to each other. So ADB, triangle ADB, is congruent to triangle ADC because of right angles, hypotenuse and leg, which would be from 6 and 5 and 3. And then once we have triangles congruent, then by CPCTC we can say that those two angles are congruent to each other. So angle BAD is congruent to angle CAD because of CPCTC. And that does it for today.